Good morning and welcome to the Unit 4 Solving Multi-Step Equations review. In this unit, we are going to be able to solve equations with variables on both sides, solve rational equations, and solve literal equations. To start out, we are going to talk about a way that we can remember on how to solve these equations and the steps that we are going to take to solve them. The phrase that we are going to use is "don't call me after midnight." DCMAM. And each individual letter here represents a different part of the equation. The first step that we are going to take is to distribute. We want to go ahead and show the distribution of a number or a variable throughout. So for an example, 3 and 2x plus 4. When I show the distribution, I'm taking the 3 and sharing it to both the numbers to arrive at, and the operation that we are going to use is multiplication. So 3 times 2x plus 3 times 4, which will give us 6x plus 12. Next step is to combine like terms. And in order for us to combine like terms, they need to be on the same side. So for example, if I give 4x plus 5x plus 9 and minus 3. The like terms that we start off with is 4x and a positive 5x. So 4x plus 5x gives me my 9x. And then the second terms that I talk about are a positive 9 and a negative 3, which would give me a positive 6. After we complete the first two steps of distributing and combining like terms as long as they're on the same side, the main goal of a solving equation is to move to isolate the variable. And we want to do it on one side. It does not matter which side, the right or the left. The way that we are going to move to isolate the variable is by adding or subtracting. And finally, multiplying or dividing. Ultimately, we are trying to find one final answer for this equation. So let's go ahead and dive into some examples. The first example we have is 1/3 t minus 6 is equal to 15. And I know that a lot of people are going to want to change this into a decimal, but because of 1/3 being a repeating decimal, I want to keep it as a fraction. So I have 1/3 t minus 6 is equal to 15. And I'm going to use my acronym here, DCMAM, to help me explain the steps. So first, I don't have to distribute. I don't see any parentheses. I have no combining like terms. Now I'm going to start to isolate the variable. And the way I'm going to do it is I want to keep that t by itself. I'm going to add 6 on both sides. So I'm going to have 1/3 t is equal to 21. I've gone and isolated my variable, and the last step is to multiply or divide. And this first example that we have is very good because we are going to actually multiply by the reciprocal of the fraction. So I'm going to be left with t is equal to 63. And that would be my final answer. The way that I can check my work is if I substitute this in for the variable. So 1/3 times 63 minus 6 should equal 15. I'm going to have 21 minus 6 is equal to 15, and 15 does equal 15. That's just a way that we can check our work. In this equation, 5 times the quantity x plus 2 is equal to 7 times the quantity 4 minus x. I'm going to continue with my DCMAM. And I'm going to start off with distributing. I'm going to distribute this 5 to the x plus 2, and then I'm going to distribute the 7 on the other side to the 4 minus x. Because they are on different sides, this 5 does not get distributed to the 4 minus x. So again, when we distribute, the operation that we use is multiplication. So I'm going to get 5x plus 10 is equal to 28 minus 7x. And with this x, there is an imaginary 1 in front. You can place it in there if you so choose. I'm done distributing because I have no more parentheses. I look to combine like terms, but because they are on different sides, I can't. Now I want to move to isolate the variable. I have a 5x and a negative 7x. I want to try and keep my x positive as much as I want, so I am going to go ahead and add 7x. I'm going to have 12x plus 10 is equal to 28. And then I am going to subtract 10 to isolate that variable by itself. 12x is equal to 18. I'm going to divide by 12. And I'm going to get x is equal to 9 over 6, or 3 over 2. And 3 over 2 as a decimal does come into 1.5, so my answer is B. Now, as we went through, I just kind of started flowing with the equation, but I was still using my DC MAM here. At the step that I am going to highlight is where I started moving to isolate the variable by addition or subtraction. And down here is where I divided or multiplied. Next question, 3x. 3 times the quantity x plus 5 minus 10 is equal to negative 2x plus 10. Again, I'm using that DC MAM to help me solve the equation. First step, I want to distribute. Distribute the 3 to the x plus 5. I am not distributing it to the negative 10 because it is not underneath the parentheses. I'm going to go ahead and distribute that negative 2 as well. So I'm going to get 3x plus 15 minus 10 is equal to negative 2x minus 20, because we know a negative times a positive is a negative. So I've completed my distribution. The next step that I have to take is to combine like terms. In this example, I do combine. I have a positive 15 and a negative 10. So I'm going to have 3x plus 5 is equal to negative 2x minus 20. I'm done combining like terms. I can cross that off. Now I start to solve the equation. I have 3x and a negative 2x. Again, I want to keep my x's positive as much as I can. So I'm going to add 2x. 5x plus 5 is equal to negative 20. I'm starting to isolate my variable. I'm going to subtract 5 to get 5x is equal to negative 25. I have isolated my variable by adding or subtracting. Final step is to divide by 5, and I will see x is equal to negative 5, which gives me answer choice B as well. I have a word problem. In the word problems, I want to look for the most important information to write my equation. So again, I'm going to highlight, and on your test you can underline. A state park charges admission of $6 per person. I know that's important because the word per is there. Plus 3 for parking. And then Joe here paid $27 when her car entered the park. Write and solve an equation for the number of people in Joe's car. So to start out, this word per is a key word. That helps me explain that that is going to be my rate of change or my slope. So I'm going to write my equation as 6x plus 3 is equal to 27. I keep true with every question that I've been doing with my DC MAM. I don't have to distribute. I don't have to combine like terms. I do have to move to isolate, and I'm going to subtract 3. Have 6x is equal to 24. My variable is isolated on itself. The final step that I need to take is to divide both sides by 6. X will equal 4. X equals 4 is not my final answer because it's asking for the amount of people. Therefore, I have 4 people in the car. The next is these rational equations. And with these rational equations, yes, we do continue on with our DC MAM, because nothing changes. The only difference is I am introducing those fractions, and we will notice that the fractions are going to work out nicely with the numbers underneath. So 1/3 works nice with 9 and 3 when we distribute, and the 4/5 works with 15 and 25. So 1/3 times 9 is going to give me 3x plus 1 minus 4 is equal to 4/5 of 15 is 12x, and 4/5 of 25 is minus 20. I have to combine like terms because I have a positive 1 and a negative 4 on the same side. 3x minus 3 is equal to 12x minus 20. Again, distributing done, combining like terms done. Now I want to isolate my variable. I talked about keeping that x positive. I have a 3x and a 12x. I'm going to subtract 3x. It's okay that I start working on my right side of the equation. Negative 3 is equal to 12x minus 3x is going to give me 9x minus 20. I'm going to add 20 to both sides. Now I'm going to have 17 is equal to 9x. Divide by 9. And I get 17 over 9 is equal to x, and that would be my final answer. Again, here in algebra, we do not want to have decimals. We want to keep it as a fraction. The next part of this unit was the literal equations. The literal equations is ultimately solving for a variable by rewriting the equation. And we practice this a lot when we are trying to take our standard form equation into our y equals mx plus b form. So as a reminder, my standard form of an equation is ax plus by is equal to c. And when we convert it to my slope-intercept, y equals mx plus b. So to start out, we're going to look at a few examples. I'm looking at the area of 1/2 times the height, base 1 plus base 2, or the area of the trapezoid. And I'm going to solve for two of these, where one will be the height and one will be for one of the bases. So we'll start off with the height. Area equals 1/2 height times b1 plus b2. First step I want to do is I want to get this 1/2 away. So I'm going to multiply both sides by the reciprocal of 2. So I'm going to have 2a is equal to h times b1 plus b2. Because the b1, b2 are in parentheses and the h is by itself, I want to divide by what's in that parentheses, that b1 plus b2. This will now isolate my variable h. So I'm going to have 2a divided by b1 plus b2. And we're going to put that in parentheses to stay consistent, is equal to my height. There would be my final answer. Now, if I was solving for one of the bases, so 1/2, where the area is 1/2 times the height, b1 plus b2. So I'll start off with, again, I'm going to multiply by the reciprocal of that fraction of 2. So I'm going to get 2a is equal to h times b1 plus b2. And again, we talked about it. Between the h and the b1 plus b2, there is a multiplication. And I'm not going to divide by what's inside, but multiply by that h. So I'm going to have 2a divided by h is equal to, because I divided by the coefficient out in front, the parentheses disappears, b1 plus b2. Now, in order to solve for, it does not matter which base, you are just going to subtract. So if I'm going to solve for b1, I'm going to subtract by b2. And my final equation is going to be 2a divided by h minus b2 is equal to b1. And if I was solving for b2, b1 and b2 would just be reversed. For this example, 1/2 times the height, 1/2 times the height times 2 plus negative 4b, and we're solving for height. This is just like a previous question that we did. Area will equal 1/2 height times 2 plus a negative 4b. I'm going to start off by multiplying by the reciprocal of 2. So I'm going to get 2a is equal to height times 2 plus a negative 4b. And because I want the height by itself, I will divide by what's inside the parentheses. So my final answer for this equation is going to be 2a divided by 2 plus negative 4b is equal to the height. And that's all the time we have. Thank you for watching, and we'll look for the next video.